Why is DevOps important? Let's look at this graph here. This graph shows us that things get more expensive over time. And the main thing that gets more expensive over time is defects. The longer it takes from a defect being introduced in a system, in a piece of software, and it being discovered, the longer it will take, the more expensive it is to fix it. And that expense is measured not only in money, but in time, in frustration, in developer happiness, really. So the longer it takes from a defect being introduced to it being discovered, the more expensive it is to fix it. And that has ripple effects. Because of that, it gets more expensive to maintain software over time. It gets more expensive to do new development. It gets more expensive to change functionality and even to support an existing system. And that is all driven by the fact that it gets exponentially more expensive to fix a defect the longer it takes to find that defect. So people thought about what can we do to move that all to the left, to have defects be found as early as possible in the system. And that process of moving things to the left is called shifting left in the industry. And what we came up with what the industry came up with is a number of processes and tools that help you find defects early. And all those we commonly now call DevOps. So let's look at this graphic again that I showed you yesterday. This graphic shows how in a DevOps environment development works. But it also demonstrates DevOps really is about introducing feedback loops, introducing many short feedback loops as early as possible. So if you look at this here, you see pair programming mentioned there. Pair programming is one of those feedback loops. If one developer types in code and makes a defect, introduces a defect, there is somebody sitting next to that developer and paying attention. They're probably gonna catch that problem, which makes it immediate feedback, which makes it very, very not costly to fix that defect at that phase. But even two very awake developers will not catch all problems. That's why we introduce unit tests. Unit tests, particularly if you follow test-driven development, help find a lot more defects. Unit tests are particularly good at finding defects of the style of one-off. Like you have a boundary condition and the code is using a grader instead of a grader equal. Those type of defects, unit tests are particularly good at catching. You're dealing with a set and there are some special values that you didn't think of. If you follow TDD practices, you're much more likely to think of those, and then you have a test that makes sure that your code behaves as expected in there. So unit tests will not find all defects, but if you do unit testing well, they will find very many defects. And it is still very early. If you follow the process of writing a little bit of code, making sure your unit test passes, which means you wrote the unit test first, you write your unit test, you make sure it fails, and you write a little bit of code, just enough to make that code pass, that unit test pass. Then you write your next unit test, write a little bit of code to make that unit test pass, and so on. If at any point in that process you end up breaking one of the older unit tests, you get that feedback immediately, which is why you want to run all your unit tests as often as possible. So you get that feedback very quickly, which again means you still know what you just changed that introduced the problem, which makes it a lot easier, a lot simpler to fix that problem. So that's why we write unit tests, and that's why we run unit tests locally. But now, once you have written your unit tests, once you have written your code and you're happy with it, and you submit a pull request to the source repository, source control repository, let's say you're using Git. In the meantime, other people might have changed other things. So you need to make sure that your changes work in the bigger picture and they do not just work in your environment. And that's where continuous integration comes in. Every time you submit a pull request, even before it gets merged, it should get tested, should run. You want to run the code in a specialized environment and run all your test cases against the code there. So that's where an automation server comes in. An automation server spins up a new environment, compiles the code, deploys the code into that environment, and then runs all the unit tests against it. And if you find a problem in there, because the change you just did is not compatible with another change somebody did at the same time, or maybe there was something special about the environment you developed in that is not the case with other environments. Those types of defects will get caught here. And by the time that the message that there is a problem comes around, more time has passed. So fixing those defects is a little more expensive, but it is still significantly cheaper than finding defects later in production. So only after the CI environment has certified the code, has certified the change, you merge the code into, say, the main branch in your source control repository, but also the code that you ran the tests against now gets stored in an artifact repository. And from there, another automation server, continuous deployment automation server, pulls it and then deploys it to a target environment. And those target environments, you might have multiple of them, could be a testing server that the QA team uses. It could be an environment where you run performance tests, or it could actually be production. And if you find defects in any of those environments, again, it is more time has passed, so it is much more expensive to fix those defects. But because you have all those other feedback loops in place, there are not going to be that many defects that make it into production. So that is what DevOps is. Now, what are actually the benefits? The benefits is because you find your defects earlier, because you end up having fewer defects that make it to later stages. You save a lot of effort, you save a lot of time, which in turn means you have now more time to do new features. Every developer wants to do new features. That is what is fun. Running after defects is not necessarily fun. So by using DevOps, you get more time to do fun stuff. But a thing that the business is very interested in is you also reduce the time it takes to introduce a new feature and deploy it into production, make it available to the end user. So you reduce the feature to market time significantly. You also will, as a developer, you will be more confident in what you can do with the code. You will be more confident that you can add a new feature. You will be more confident that you can fix a problem. There will be less of those moments where you think, what was I thinking when I wrote that? Or what was whoever thinking when they wrote this? And yes, that confidence is a really great feeling that then in turn speeds everything up again. So you spend less time thinking about what you need to do to make sure that you don't break anything else. Because if you break anything else, you will get that feedback very quickly. So you don't necessarily need to spend as much time up front thinking about how to prevent it. But most importantly, you will have a significant reduction in on-call. The first time I was in an environment where DevOps practices, and that was very early on still, but DevOps practices were used, we managed to get on-call down from several calls every week. Code that we were working on was basically only executed on weekends. So really it was several calls each weekend. That was before we started DevOps, and then we implemented DevOps practices, including rigorous unit testing. And after a year or two, we got to having about 4 on-call calls in an entire year. So you will, if you do DevOps well, you will see a significant reduction in on-call. And again, that will make your developers happy. So executing DevOps, executing unit testing, executing all this automation, there is an upfront cost. And there is an upfront cost to every feature that you implement. But you get so much benefit from it that it is definitely worth going that way. That is all I have for you today. Thank you for showing up. If you have any questions or comments, please leave them below. If you liked what you saw and if you want to see more content like this, please subscribe. Thanks for watching and have a fantastic day.